In this lesson, you will learn how to build your LabVIEW code into a standalone application and how to create distributions to share with others. Now let's discuss the steps that you need to take to prepare your LabVIEW code for distribution. First, you need to save all changes that you made to your code. This includes changes to the project, the VIs, and any type definitions. Next, you should review the paths to any files that your code accesses. Finally, you should use the VI Properties dialog box to customize the appearance of your application. Conditionally, you can call the quit LabVIEW function. Make sure that all your VIs are saved in the latest version of LabVIEW. If your application has more than a few VIs, manually opening and saving each VI can be tedious. Instead, you can choose to mass compile all of the VIs in a given directory. To do this, go to Tools, Advanced, Mass Compile. In the resulting dialog box, select the root directory that contains all of the VIs that your application calls. Use the VI Properties dialog box to customize the window appearance and size. You might want to configure a VI to hide scroll bars, or you might want to hide the buttons on the toolbar. Suppose you read data from a file in the application, and the path to the file is hard-coded on the block diagram. Once the application is built, the file path is embedded into the executable. If the executable runs on a different machine, the file path will cause an error because the path is different when the executable runs. It's recommended to set paths relative to the application directory VI path. Now let's examine how the Get System Directory VI behaves. Regardless of whether the calling VI is part of an application, library, or built executable, this VI always returns the path to the specified Windows system directory. In this case, we generate the path to a log file that will be stored in the Documents system folder for the current user. This approach is useful for when you want to programmatically generate a path that is relative to a fixed Windows folder instead of the calling VI or executable. Now let's In a standalone application, the top-level VI must quit LabVIEW or close the front panel when it is finished executing. To completely quit and close the top-level VI, you must call the quit LabVIEW function on the block diagram of the top-level VI. The runtime engine symbol specifies whether the subdiagram executes when you create a LabVIEW standalone application or shared library that uses the LabVIEW runtime engine. Build specifications contain all of the settings for the build, such as what files to include in the build, the directories to create when the build executes, and settings for the VIs to include in the build. To use build specifications, you must have the Application Builder installed on your computer. The Application Builder is part of the LabVIEW Professional Development System, or can be purchased as an add-on to the LabVIEW Base Development System or Full Development System. Click each type of deliverable to learn more about it. The system requirements for running your executable are generally the same as the requirements for running it with the LabVIEW development environment. That is, the target system must contain all of the hardware and drivers that the application needs in order to execute. The memory requirements for the built executable may be different for the deployed system. The executable requires only that you install the LabVIEW runtime engine on the deployed system. You do not have to install the full development environment on that system. Now I'll configure the executable for the Event-Driven State Machine project. I'll begin by creating a new executable for the build specification. In this demonstration, I'll set the exe properties in these categories: Information, Source Files, Advanced, and Preview. The exe is typically used on a computer other than the development computer where it's built. I'll change the name for the build specification, and then specify the name of the target file name. Next, I can specify a known destination for the generated executable files. Send all builds to a destination folder that is cleaned up regularly, like a temporary folder. This will avoid having several build files take up space on the development computer. Moving on to the source files, the exe needs at least one VI to be a startup VI, but more than one is allowed. I'll specify the startup VI here. If you have statically linked files in your project, do not include them as they are always included automatically. You do have to include any dynamically linked files in the Always Included section. I can specify them here. In the Advanced area, you'll need to consider enabling debugging in the exe, which I can turn on. Typically, an exe runs on a machine with the LabVIEW runtime engine only, so there is no way to look at the block diagram. However, a different PC with the LabVIEW development license installed can connect to the exe provided they can see each other over the network. This other PC can then be used to debug the exe using debugging tools such as execution highlighting, probes, and breakpoints. The last item is the Preview pane. This is where you can see the directory structure and files that will generate when you build the exe. Clicking OK saves the build specification and closes the My Application Properties window. After creating the executable, you'll want to click the Save All button to save all files associated with the project, including build specifications. Then, right-click the build specification and select Build to create the executable. The Build Status dialog box appears. When the build finishes, click Explore to open the directory that contains the new executable. Run the executable by double-clicking the exe file that was created. On Windows, you may be asked to allow the executable access so the application can communicate through the local firewall. If this application does not run as expected, you can debug the executable on the same computer. This works only if you enable debugging in the build specification. Click each step to learn more about the process. Building an installer ensures that the application installs with the correct version of the runtime engine. Applications developed in LabVIEW 2019, for example, require the LabVIEW 2019 runtime engine. If an application relies on drivers, like NI-DACMX, they will also need to be installed on the target. An installer ensures the necessary drivers are installed. If you have just one destination machine, copying an exe and separate installation of support drivers and files might work. However, to replicate the application on several machines and ensure that files are copied over correctly on each, it's best to rely on the reproducibility of an installer. Professional applications are almost always distributed using installers. For example, customers expect to run setup.exe on any Windows machine they are installing software on. In the Installer Properties dialog box, you should include the LabVIEW runtime engine and include other drivers used in the application. Refer to the LabVIEW help for more information. Use this page of the Installer Properties dialog box to name the product for which you're building an installer and to select the location of the built installer. Here's where you add files to include in the installer. Files that a build specification include appear dimmed in the tree because you cannot add or remove individual files generated by a build specification. You can add or remove only the entire build specification. Make sure you include the LabVIEW runtime engine and any drivers used in the application. Finally, test the installer by installing and running the application on the destination computer. Use packages to distribute source distributions, packed project libraries, shared libraries, .NET assemblies, or executables. You can create packages and deploy them to clients through the NI Package Manager or System Link. Before creating packages, create a source distribution, packed project library, shared library, .NET assembly, or executable to include in your packages. Note, you cannot distribute standalone VIs. The created package installer can only include one main package. Other required packages can be added as required dependencies of the main package. The self-contained package installer will only include the dependencies packages with the required dependency relationship type. Other dependency packages that are recommended or suggested won't be added to the package installer. In the Package Properties dialog box, under Information, enter the name you want to use for your package in Package Name. The package name must be all lowercase and contain no spaces. NI Package Manager and other packages use this name to reference the package you create. Under Destinations, set up any destination folders where you plan to install the package on the client. Here is the default package installer destination. Under Source Files, specify which files or build specification outputs you want to install. Then configure the dependencies for the package. Click Build. A Windows file or NI Linux real-time file appear in the destination you specified. You can distribute the package to clients through the NI Package Manager or System Link. Note, the NI Package Manager does not support .ipk files. Here's a summary of what you've learned in this lesson.